Now let's look at an expected value example from the insurance industry. Okay, there is a 0.99791 probability that a randomly selected 49-year-old female survives through a year. An insurance company charges $620 per year to insure a 49-year-old female for $250,000. So what is the expected value for a 49-year-old female who buys this policy? Okay, let's scroll up and get a little bit of room here. Okay, so our possibilities now, like in gaming, we said the person wins or they lose. In a life insurance, they either live or die. So we'll set up our table with our values for X, and either I'll make a note over here, if the person lives, okay, well if she lives, she doesn't get the $250,000, and she's out $620 for that year. Obviously she won't get the $250,000, her beneficiaries will, but that doesn't happen. What happens if she lives is that she loses the $620. If she dies, then the net gain here to her beneficiaries is the $250,000 minus the $620. So let me make a note up here. I'll just do it here. We want $250,000 minus $620. That's already been paid, so that's $249,380. Okay, so $249,380. All right, what's the probability of these two outcomes? Well, the probability that she lives, well, they gave us that, right? That's what this is, the probability that a 49-year-old female survives the year. 0.99791. So what's the probability that she doesn't survive? Well, clearly that's 1 minus 0.99791, because they would be complements of each other. These are the only two outcomes, and that's 0.00209. As always, the sum of the probabilities in our sample space must equal 1. Okay, so to find the expected value, recall that we take the sum of each outcome times its probability. So we've seen the easy way to do that is just to set up another column where we take the outcomes times the probabilities, and then the sum of that column gives us our expected value. Okay, multiplying across here, this is going to be a negative 618.7042. Multiplying across here, we get 521, sorry, 5, let's fix that real quick, 521, that's what that should be, 521.2042. Okay, so the sum of this column gives us our expected value. We get negative 97.50. So this expected value equals negative 97.50, or a loss, because it's negative, I'm saying loss, of $97.50. Okay, well, this is the expected value to the female who purchased this policy. Why would somebody purchase a life insurance policy if this is the long-term average expected and it's negative? Well, we do this because insuring the financial security of our loved ones compensates us for the negative expected values. We're doing this not really for ourselves, but for those who are dependent on us. Okay. Well, let's look at another question here. What about the expected value to the insurance company? What would be their expected value? Okay, so they think about this differently. There's still the same two outcomes. The woman lives or the woman dies, right? And we'll find a probability for each one of these. But now, if she lives, the insurance company got $620, right? They charged her $620. They get to keep that. If she dies, let's go back up here. They're out $250,000 minus the money they already got. So it's the same number here, right? So if she dies, they got $620. They have to pay out $250. So they've only lost $249,380. $249,380. But this, if the woman dies, that's a negative for the insurance company, right? So what does this look like? Look at our tables. Here, if for the woman, if she lives, she's out the $620. For the insurance company, if she lives, they get the bonus of, or they're up by $620. So the signs just change, right? Depending on the viewpoint of the woman, the viewpoint of the insurance company. These probabilities aren't going to be any different. 0.99791 and 0.00209. And again, they sum to 1. Okay, so that doesn't change. What changes is what's positive and what's negative here, because it depends on the viewpoint of the insurance company versus the person. So we'll multiply across, and we'll expect to get the same results, only the signs are changed, right? So last time we got negative 618.7042, but now this is a positive 7042. And last time this was positive, and now it's negative 521.2042. So we add these together for our expected value, and this time we get a positive 9750. Okay, so our expected value here we got 9750, or we would say a gain, because it's positive, of $97.50. And we expect that because the insurance company has to make money, right? And they know that some people will die and some people will live, and in the long run they've got to end up making money. We do this, we make this purchase knowing there's a good chance we're going to lose, for example, the long-term average loss of $97.50, but we do that because the benefit is security to our loved ones. Okay, so we as people purchasing insurance can compare policies this way, and insurance companies can use this kind of calculation to determine how much they should set the price for, right? Based on these probabilities, the statistics of how long people live, and how much the insurance will pay out, and they can determine, how much they expect to earn based on that. So they've got to determine, how do I set the price for a $250,000 policy for a woman who's 49 years old? Well, they could run through this calculation, or an example of this. If we look at, what if they just want to break even? Okay, now that wouldn't be their choice, but we'll see how breaking even could be calculated, and therefore they could set that expected value to be whatever they wanted. Say they'd rather it be, instead of $97.50, $100. But let's just look at the calculation of what if the insurance company says, we don't want to make money, but we don't want to lose money in the long term, so what if we just want to break even? Well, let's look at how we might calculate that. So again, expected value is the sum of each outcome times its probability. Okay, so our outcomes are that she lives, I'm just going to write them above my equation here, or she dies. Okay, so if she lives, let's think about this. Our X represented the cost of the policy. Right? And that's a gain for the insurance company if she lives. Gain for company if she lives. They get to keep that. That's what it represents. Okay, well, it's a $250,000 policy, so we said X minus $250,000. This is the loss for the company if she dies. Notice that you would get a negative number because the cost of the policy is going to be way less than $250,000, right? So this is a smaller number. We get a negative. Negatives represent a loss, okay? So that's the loss for the company if she dies, okay? So we can write out an equation here and say that if she lives, then they get the cost of the policy times the probability that she lives. Okay, that's the X times P of X here. All right, plus, and then if she dies, this value is, we have an X times P of X here. So let me just write it that way. We have X times P of X. So below, let's fill in what we know. This is our X1, this is our X2. So here's our X1, and here's our X2. These are the two outcomes. Okay. So we have the cost of the policy times the probability that she lives, plus, that's if she lives. The expected value is based on that outcome, then the outcome if she dies. Well, now we have this loss if she dies. The insurance company has to pay, but they get to keep the $620, or whatever this number is. We're trying to determine how much it should be. And that times its probability. This is the probability that she dies. We had already calculated. And we're saying, what if that equals 0? Okay, so let me just, this is what we set up. Let me just erase this equals. Now we've got an equation here. We want to know, what is X? If X times the probability that she lives plus, this is the cost of the policy, plus the cost of the policy minus what they pay out times the probability that she dies is 0. So we've got just an algebra problem here, right? We've got an equation to solve. So let me write this in a way that looks more familiar. So this would be 0.99791x, and now we'll remember that distributive property. I'm going to multiply this times this and this times this. Okay, to get, I'll just keep this color. Okay, so when I do the first one, I get 0.00209x minus, this will be a negative, positive times a negative, 522.5. And all that equal to 0. So now it's really simple. I want to combine like terms. And here we get, that adds up to 1x minus 5 522.5 is equal to 0. Then of course we add 522.5 to both sides. And we get x is equal to 522.5. So, in the first problem, in the first part of the problem, they were charging $620, and the expected value for the insurance company was $97.50. And the question was, well, what if their expected value is 0? How much should they charge? And they would charge $522.50. So, to break even, the policy would cost $522.50. Now, maybe this is where they would start in pricing policies. All right, what's my break even? Okay, how much can we raise this to be competitive in the marketplace? You know, what are other people charging a 49-year-old woman for $250,000 of insurance? And we know we have to go above this. We've got to make money. How high can we go and still be competitive so that people will buy our product? Okay, so this would be kind of an understanding of how they might go about getting a starting point and therefore then to price their policies.